So see, wagon of mass 600 kg is towed by another wagon 1000 kg at a uniform speed. If all resistance to motion amounts to 2 Newton per kg, so that means that this becomes 2 times 600 for every mass. For every mass, yeah, it experiences 2 Newton per kg. So 2 times 600. Reaction force. So that means that this first body, let's say this is T1, force on a rope is tension. So this first body is going to be, the total force on this first body will simply be this T1, that is its forward force, minus the resistance, and the resistance is 1200, is equals to mass of the system. And notice that the question says at uniform speed. At uniform speed, the acceleration is 0. So at uniform speed, the acceleration is going to be 0. So that means that everything here is equals to 0. So t minus 1200 is equals to 0, which means that t is equals to crossing over 1200. So the force, remember that this t, where t means tension force. Tension force. Now for the second body, it's going to be the forward force minus the resistance on it. So this is more like, I told you that any object that is in horizontal movement has two forces acting on it, the forward force and frictional force. But when frictional force is not stated, if it's just one object, it will just be the forward force. So, but in a case where it is stated, this place they stated the frictional force. So if for the second body now, it will have its forward force and frictional force that is acting on it, then this one that is trying to pull it back as well, the tension that it will experience from this object. So that means that it will have its forward force minus the frictional force, which is this reaction force 2000, then minus the tension experienced from this, and that is 1200, then equals to the mass of this system, then times acceleration. But you know that acceleration is 0 at uniform speed. Acceleration is equals to 0. Remember I told you that acceleration, always see acceleration this way, see deceleration this way. This is uniform speed. So you see that at uniform speed there is no acceleration, no rise, so it's 0. So it's going to be 0. So everything here is equals to 0. And this is the sentence saying f minus 2000 minus 12 is the sentence saying minus 3200 equals to 0. So f here is equals to 3200 Newton. Okay. Now remember they asked us the pulling force of the 1000 kg wagon. So the pulling force of the 1000 kg wagon, which is this force, that is it here, is 3200. Now they ask us the change in pulling force assuming the two wagons accelerate at 4 meters per second square. So it's no longer when uh it's uniform velocity, but now they said the change in pulling force, assuming the two wagons accelerate at 4 meters per second. All right, remember that in that case, pulling force will be equals to MA. Are you seeing it? Pulling force will be equals to MA. So it's simply going to be the same thing as saying 3,200 is equals to the mass of the object there. Notice that this is the body that is being pulled, which is 1,000. Then acceleration is 4 meters per second square. That's what they said. The change in pulling force, assuming the two wagons accelerate at 4 meters per second square. Okay. So this is going to be the same thing as saying 4,000 equals to 3,200. Are you seeing it? So you can clearly see that so we can clearly see that the pulling force is 3,200, and when it accelerates at 4 meters per second, when this body accelerates at 4 meters per second, which is 1,000 kg, accelerates at 4 meters per second, notice that it is now having a new force, which is 4,000. So we can say that pulling force is equal to 4,000. So we can see that the change is simply 4,000. So if we do this now, we can clearly see it that it's equals to 3,200 is equals to 4,000. Remember that force is equals to MA. This is the pulling force. Then this is the mass when it experiences 4 meter per second square acceleration. It gives you 4 newtons. So this is it. This is it. So pulling force is equals to 4,000. That's the change. But another way to do this is simply saying F minus 2,000 minus 1,200 is equals to 1,000 times 4. This will give you 4,000. This will give you minus 3,200. F equals to. So by the time you cross this over, F is equals to 4,000 plus 3,200, which is equals to 7,200. And this thing is confusing. There's no use for this. So what we simply do is when you get 7,200 now, you now ask yourself, the 4,000 that you just made, or that you just got, minus it. You simply do the change. Since you have now 7,200 minus the pulling force from it, because we know that pulling force is 3,200. It still gives you 4,000 Newton. So this is the change in pulling force. That is it. All right. Next question says, describe weight. The way I like to define weight is simply that it is the force which acts on a body that tends to bring it towards the center of the earth. That's the way I like defining it. Or you can say weight, or you can say it is the force that acts on a body that causes it to accelerate downwards. Whichever way you want to remember it. So you can also say that weight is the vertical force on a body. Vertical force on a body which acts downwards. Whichever way. And we say that weight is given by mg. You see it, weight is a force and is equals to mg, where g is acceleration due to gravity and is equals to 9.8 meter per second square. So they say describe apparent weight. Apparent weight is mass. It is the amount of matter. They say describe apparent weight. Apparent weight is mass. And then if apparent weight is mass, it is the amount of matter contained in a body. When you go and say, I'm going to check my weight, that thing you're checking is not your weight, is your mass. That's why you get it in kg. So the unit of weight, weight itself, the unit of weight is Newton. Why the unit of mass is kg. In physics, SI unit of weight is SI unit of apparent weight, mass, is kg. While in chemistry, we normally use gram. Why weight, the SI unit is Newton, is force. All right. What is the weight of a 75 kg astronaut on Earth and on the moon? Question 15, 16. Okay. And you say 14C. John 14C. Remember I said that 14B is mass. $750 Newton. Gaskiya Oga. That's the answer. Then they said on the moon. Okay. A package scale is placed on the floor of a lift. You go and watch my video on when a body is moving upwards and downwards, the dynamics there. The body of mass sits on top of the scale. What is the reading on the scale as the body accelerates up and down? Without stressing you. When a body, you need to remember that force, once you see any question, force acting on a body upwards is normal force. The one downwards is mg, or you call it weight. And if that be the case, it simply means that when the body is still at rest, normal force will be equals to weight. There will be equal, so N will be equals to mg, because there will be no acceleration. Or you can do it this way. You can say any of them minus each other will be equals to me, and a here will be 0 because there is no movement, so everything here will be equals to 0. Now upwards, when moving upwards, whenever a body is moving upwards, acceleration due to gravity is negative. So that means it will affect the weight, because weight carries g, mg. So that means that any now will be the same thing as saying, or you say since it's going up, any will be positive, is favored, any is favored, is going in the direction of normal force, upwards, minus weight equals to me, and there's acceleration here. There's acceleration, so acceleration will not be 0 again. So remember that this is mg, n equals to me. So this can be the same thing as saying n equals to me plus mg. That is when it cross. And for a body to go upward, for a body to be able to go upward, it means that it was able to overcome gravity, even though it will still come down. So that means that mass is greater than, apparent weight is greater than weight here when it's going upwards. So see that we can factor out to have a plus g right here. So we can say weight less than apparent weight, or less than mass here. Now when downwards, when it's going downwards, whenever a body is coming downwards, it means that gravity is in charge. Gravity has overcome it. So for that reason, n will be minus, w will be positive, equals to me. There's acceleration there, movement. Always think of acceleration as movement. So plus mg, weight means mg. So when it crosses over, it becomes so notice that this can be the same thing as saying m into e minus g. So to make n subject of formula, normal reaction, or you say normal force, this is going to be now any, that is minus 1 dividing both sides, equals to, crossing over, it becomes minus m into e minus g. You can leave it this way, or you can say that this is the same thing as saying so whichever way you want to remember it. So for downwards, for upwards, and at rest. So that means that when it's coming down, weight is greater than mass. Alright, that's what they want you to check there. The next question says, a boy weighing 60 Newton stands in an elevator that is ready to move. Find the boy's apparent weight, the resultant force acting on him as the elevator moves upwards with acceleration of 3 meters per second square. Take g equals to 10 meters per second. Alright,